All right, here we go. Speed and velocity. So you can either A, go to the link. It's kind of this link. They keep changing the link, so you'll have to just access it through Canvas and make your way to where it answers this, or I can just go over it. I'm going to sort of go over it anyways because the link's hard to navigate. So speed and velocity. All right, number one, it is a review, so technically you should know a lot of this stuff. A quantity that is fully described by magnitude alone is a blank quantity. So let's go over these terms first. First off, magnitude just means a number, a raw number to describe something, right? A scalar is very similar, a raw number to describe something on a number scale. Vector is like a number scale with a direction also, right? So a quantity that is fully described by magnitude alone means only magnitude. I'm 5'7". Right? Magnitude, that's it. That is scalar. A quantity that is described by magnitude and direction, that would be a vector. So a vector quantity would be like a magnitude with a direction, right? So number one's A. Good. Number two, speed is a blank quantity and velocity is a blank. By now, I mean, you guys should know this like easily, right? Speed is just a straight up raw number, whereas velocity is your speed with a direction, right? So scalar, vector. Pretty easy. All right, number three, state the equation for calculating the average speed of an object. Well, remember, velocity equals distance over time. Easy money, right? All right, number four, an object moves uniformly in a circle, can have a constant blank, but a changing blank. Okay, so think about this, right? It's moving in a circle, and let's think about the definitions of each, right? Speed is just a quantity, a number, whereas velocity is a speed with a direction. So if it's moving in a circle, it can have a constant speed. However, its direction is constantly changing, right? Because it's going in a circle. Like if I'm driving in a circle on a roundabout or whatever, I'll have a constant speed, but my direction is always changing. So constant speed, changing velocity. Very good. A lot of A's. 5. The direction of the velocity vector is always blank. Circle all that apply. So, in this case, I'm going to make my circle here. So there's two vectors going on here. There's a velocity vector and there's an acceleration. So, velocity vector is always, it's always sort of like tangent to the circle based on your direction. So it's pretty much always going to be like out if this is going counterclockwise, we'll say. So these are your velocity vectors, and then this is your acceleration is always towards the center. So in this case, number 5, velocity is in the same direction as the net force and in the same direction the object's moving. So there you go. All right, true or false? The direction of the velocity vector of an object given at an instant in time depends on whether the object is speeding up or slowing down. So that doesn't matter if it's speeding up or slowing down, right? So that's false. Because exhibit A, right? All right, for an object moving in a uniform circle, the velocity vector is directed blank. All right, so we just said this one. This is going to be, so it's not outward and it's not inward, right? It's always tangent, which is this. Bam, 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 kind of depending on where you are, right? So this is going to be C, tangent. In a direction of the tangent line drawn to the circle at the object location. All right, number 8. Use your average speed equation, average velocity equation, to determine the speed of A rider on a carousel that makes a complete revolution around the carousel. That's the diameter, that's the time. So first off, let's get everything else. So for circumference is 2 pi r. Our formula is velocity equals displacement over time. Right, so d over t. And let's put everything off to the sides. First off, the radius is what? We'll just use diameter. 2 pi r is pretty much diameter times pi, right? So my diameter is 21.2. My time is 17.3. And that's it. So, all right. Okay, refresh time. So they're on a carousel. Carousel's going in a circle. Our base equation is going to be velocity is displacement over time. Pretty much distance over time, right? Now, the distance of this circle, they don't really tell us, but they do tell us the formula for circumference, which is essentially our distance in this one, right? So instead of distance, we're going to put the circumference in place of this because that is the distance, right? Let's move this up a little bit. So our velocity is going to be 2 times pi times the radius over time. This is taking the place of this because this is our distance, essentially, because that's the circumference, which is distance. So 2 times radius is just the diameter, so we're going to rewrite this as velocity equals 21.2 times pi over time, which I guess our time is 17.3, so I'm just going to put 17.3. Hopefully this makes sense. We replaced 2 times pi, so doubling the radius, 2r, is the diameter, so we're just going to put diameter pi over time. And that's going to be our velocity. So, do that calculation, and you should get velocity equals 3.85. And then meters per second, right? Because that's our units. We always got to put our units in. Good. Next, your clothes that are plastered on the wall of the washing machine, in other words, they're in the washing machine on the spin cycle, make a complete revolution. This is our diameter, and this is our time. So we got to find the velocity again. So same deal. Our diameter is going to, let's convert that to meters, right? So that's 0.619 meters. Velocity equals 0.619, because we converted it to meters. We don't want centimeters, times pi over time, and they give us 0.285. And that should give us 6.82 meters per second. Make sure you guys are doing these before you get the answer, please. All right. A roller coaster traveling over the crest of a hill. Roller coaster traveling over the crest of a hill and is at the location shown. Side view, draw an arrow, the direction of velocity. Remember, velocity vector, so this is a roller coaster, is just tangent to the circle, the direction it's going, essentially. So in this case, boom. Right? There you go. Speed and velocity page is done. Great job, guys. Great job, me, but good job you guys too.